let's go through LeetCode number 39 combination sum. And for this question, it gives us an integer array candidate and also a target. You can use the same number from the candidates unlimited times of number of times to get those kind of combinations and return this integer as those combinations which will have sum equal to target. Comparing to this is also similar to what we did for the subset so far. This means that from an empty subset, we can add, for example, add this kind of tool to our result, right? When this add to it, we can add to it again, right? And then add to again, and add to again. The exit condition for this branch is that if the sum already greater than 7, greater equal to 7, we don't need to add more, so we can chunk the branches. So for subset is when this added, we have to move to the next index to S3. But now we can add multiple times. That is when this added, we can still DFS from the current index I instead of I+1, right? We can still DFS from I. The X condition is the sum greater equal to target. So let's write code for this. We'll have this integer result equals new array list. Right? Let's say the problem is that the numbers in candidates they are distinct. So for this one, we don't need to worry about those kind of deduce, since we don't need to sort this kind of integer array. We just DFS candidates, and we start from index 0, and we want this one equal to target, and we have new array list of integer as pass. And we'll have list of integer as result, just return result, right? So we have a private void DFS. I have this one can be date and int index, right? And int target. We are having call remain, right? We at the beginning it will be target, and every time we just let this number instead of add another variable sum here to add to greater equal to target, we just use the target to minus those kind of candidates we add to our sets to get a remain. And so we have list integer pass and also list integer result. So let's say the exit condition is that if remain is smaller equal to 0, we need to return, right? And only here we have if remain equals 0, we'll add our result, that is result add new array list test, right? So we also iterate for int I equals index, right? Smaller than can be dates of the length. Plus, and we are trying to add this kind of pass add nums I, and we'll backtrack, that is remove has dot size -1, right? So the thing is that we can use this every candidate multiple times. So instead for the DFS, we move to the next index. We should still have this I be start from the current one. So we'll have DFS candidate. So here we'll use I instead of I plus 1, and remain will every time we add these nums, we'll have remain nums I, and we'll have pass, and we'll have result, right? For into candy, yeah, 4. This is no fancy info. Nums. So doing like this way, the time complexity, I think it will be more than 2 power n, because for every number, it have more than 2 choices, because it can select 0 times, 1 times, 2 times, until target divide by this number, right? Those kind of selections. So this one, for example, if this is 7, so the first number will have 0 to 3. If select 0, 1, 2, 3, there are 4 types of selections, and then multiple by 7, that is 0, 1, 2, right? So those kind of combinations is power ordered time complexity, but it is more than 2 power n.